Okay, so I want to do some review here for our last few classes to make sure that everybody is remembering the stuff we've covered in the last few weeks because it's not in our textbook. So we're going to look at one similar to one we did a few quizzes ago for angled foundation. It'll look like this. We're going to put this as 120 degrees out here. We have a 28-foot span on this side and a 22-foot span on this side. This portion of roof over here is 612 slope. This wall is 42 feet, and this wall over here is going to be 30 feet long. So a couple of things we're going to be asked to find. We're going to be asked to find the slope at roof. We're going to be asked to find the floor area and the roof area. So let's start out with that floor area. This is a problem that we've done a few times, very similar at least to one we've done a few times. And if you recall, because these bands are different here, we have to cut this first like this to make rectangles on these ends, then like this to make a rectangle on this end. Of course, this is 22 feet, and this is 28 feet, rectangle. But because those slopes are different, what changes is the way we cut this piece here in the intersection here. Let me redraw that larger off this side. I have right angles there and there, 28 feet, 22 feet. Now, if we look at this, this is 120, 90, 90. This one has to be 60 to make that full 360 degrees. That's a 60-degree angle there. So to work with this piece, the way we're going to cut it is we're going to cut it across here, corner to corner. So splitting each of those right angles into smaller angles. The reason we do that is we can find the length of this piece here using our law of cosines. It would be the square root of 28 squared plus 22 squared minus 2 times 28 times 22 times the cosine of 60 degrees. My mode is set to degrees. Square root of 28 squared plus 22 squared minus 2 times 28 times cosine of 60. Close my parentheses twice. At 25.53 feet. Now that we have that, we can find these angles. I'm going to call this angle A. This angle. I know that 25.53 feet over the sine of 60 degrees equals, we'll do the shortest one first, 22 over the sine of A. So we cross multiply and divide here. 60, make sure you close that with the parentheses. Times 22 divided by 25.53 is 0.7463. And we do an inverse sine. That number to get that angle, A, is 48.27 degrees. Angle A up here is 48.27 degrees. Now there's some things we can find from that. First of all, B, we know these three angles here have to add up to 180. So we'll use that to find that B, if we add those up, is 71.73 degrees. I can find this angle up here, subtracting from 90, this will be 41.7 degrees. This, of course, is 120. This angle over here would have to be 18.7 degrees. Now we have all three angles of this triangle up here. We can find sides. Call this side here F. We have 25.53 over the sine degrees equals D the sine of 18.27. So here we will cross multiply and divide. 25.53 times the sine of 18.27. Make sure you close that parentheses, divided by the sine of 60. 9.24, so this is 9.24 feet here. Go do the same thing for F. 25.53 feet over the sine of 60 degrees. F over the sine of 41.73 degrees. .53 times sine of 41.73, close parentheses, divided by sine of 60, 19.62 we get there. Cross multiply and divide. So this is 9.24 feet, which makes this up here 32.76 feet. That's the 42 minus the 9.24. This piece here is 19.62 feet, which makes this piece up here 10.38 feet. So not much left up there. Now we can find our areas here rather easily. Find area, I'm going to go back and cut this across here. My first piece here. Second piece here is 10.38 times 22. My third piece here is 22 times 19.62 divided by 2. And my final piece right here, piece 4, is 9.24 times 28, or 28 times 9.24 divided by 2. So if we calculate those up and add them up, over 76 times 28 plus 10.38 times 22 plus 22 times 19.62 divided by 2 plus 28 times 9.24 divided by 2. We get 1490.82. That is square feet, and that is our floor area. We have the area of the floor of this piece. The area of the roof is a little bit trickier. Find the area of the roof, we're going to have to find this slope. Draw this in here. And what we have is we have 4 trapezoids. Although they can actually be folded out into 3 trapezoids, believe it or not, or into 2 trapezoids, I should say, believe it or not. Find this first trapezoid. We got a top here of 42, a bottom of 32.76. Need this distance here, that height. Those are going to be right angles. So to do that, we're going to look at that truss on the end. This is a 28-foot span, 612 slope. We're gonna run that a 14-foot run, half the span will be our run. 6 over 12 equals H 14, giving us H equals 7 feet. So this length here will be the square root of 14 squared plus 7 squared. Giving us 15.65. Multiplying by 2 to get both the full height, 31.305. So that area, remember the area of a trapezoid is the average of the bases. 42 plus 32.76 divided by 2 times the height of 31.305. Make sure you hit equals before you divide by 2, otherwise it'll mess it up. So we have 37.38 is our average of our bases times 31.305. 1170.18 we'll call it. Perfect. That's for the one side. Now we need to do the other side over here yet. We've got 30 and 10.38 on that one. We need to know this length now. To find that length, we have a 22-foot span, but we do not know the slope. We, however, know that height has to be 7 feet. That height has to be the same height as this section of roof because the peaks meet in the middle. I can actually find that length over 12 equals 7 over 11. Remember, half of the 22 is our span of 11. So if we cross multiply and divide, 12 times 7 divided by 11, 7.64. That is actually the slope of this section of roof. 7.64 and 12 slope. Obviously a bit of a special order. Find the length of this, it'll just be the square root of 7 squared plus 11 squared. Be 13.04 times 2, 27.08. That area, average of the bases, so the 30 plus 10.38 for 2, at 27.08 feet. 30 plus 10.38, again, hit equals before you divide by 2, times 27.08, 546.75, plus 1170. It gives us 1716.93. Square feet of roof area. That is the total roof area. Any questions there? Okay. Well, I want to talk a little bit about our hip roof calculation. We have here is a 28-foot span and a 14-foot setback. Now, setback's important because it tells us how our slopes relate. In this case, that setback of 14 feet is half of our span of 28. This tells us these have the same slope. 12 slope on the main roof, 8/12 slope on the hip roof. So we can actually come here and find our longest or our length of our common rafter. 8 feet on a 8/12 slope. Height, a run of 14 feet. 8/12 equals h over 14. Cross multiply and divide. 8 times 14 divided by 12 gives us 9.33 for height. So this length here is the square root of the 9.33 squared plus 14 squared. Giving us 16.826 feet. Well, since these are the same slope, that is also the length of our longest jack. Find the length of this next longest jack. Do that. 16.826 feet here. This is 14 feet, just half of our span. The next one is going to be at 12 feet, 2-foot spacing. That's X. So we have 14 relates to 12, 16.826 X. Cross multiply and divide to get X. Thus 14.222. So we subtract here to get a difference. 0.608 feet. I'm okay if you leave it at that. That would be our decrease, difference in hip jacks. The only thing we haven't found is the length of this common hip here. We found the length of the common rafter. The length of that hip is going to be found using this same dimension, but we're looking at this bigger triangle here on the angle. Actually, it'd be just the hypotenuse of this. Square root of 14 squared plus 16.826 squared. That's 21.889 feet. Difference. Common hip here. And of course, this is the longest jack of the common rafter. You look at a valley set. Let's go with spans of 28 feet and 28 feet, and the peaks match. Peaks match means the peaks just come together up here, which means that they have the same slope on both sides. This is listed as a 6/12 slope, so I have a 6/12 slope on all surfaces here. Once again, we're going to find our common rafter length. 8 feet, H, 14-foot run, 6/12 slope, 6/12 equals H over 14. Cross multiply and divide gives us H is 7. So that common rafter length be the square root of squared plus 14 squared. giving us 15.65. That's the length of our common rafter. Well, we're going to use that to find the decrease. Since the slopes are the same here, it doesn't matter which side we go on, so we can just find this one here. I'll call that y. That's 15.652 feet. So I have 5.2 here and 14 here. Remember, this distance is just half of the span. Y here, and this will be 12 feet. 14 goes to 12 as 5.2 goes to y. Cross multiply and divide. 16 or 15.652 times 12 divided by 14 gives us 13.416. Subtract there 0.236 feet. Those of you that haven't noticed yet, anytime you have a common hip or valley, common hip or valley means all slopes are the same. 612 slope. I'm okay with you leaving those as decimals for now. We can come back and turn them into feet, inches, time. I trust that you guys can do that process. We've done it enough this semester. So I'm not going to pound it into you here. So with that, I want to give you guys some work time on your test today. One thing I want to tell you is if you look at your test, problem 15 through 20, taking out the chimney here thing again. I forgot to give you that the span across here should be 36 feet. That'll make that a lot easier to do if you know that span. I did put that on there for some reason. Otherwise, that looks very much like what we did on our last quiz. So like I said, for now, I want to leave it at that. I want to give you guys some time to work on your test. Looking at your test, there are some problems you should be able to do. Number 1 is very similar to a problem from our quiz. Number 2 is very similar to a problem from our quiz. And so is number 32. Those are ones you should be able to do, hopefully remember from our processes in class. Along with what we did today, hopefully you're ready to go. We will talk more tomorrow about this stuff. For now, I'm going to let you guys go and get to work on